In this video, I'm going to demonstrate how to graph a logarithmic function that has two transformations by creating points on its inverse exponential function to the logarithm and then through the transformations. And we will just kind of walk our way through it. So in this particular case, we will have f of x equals negative logarithm base 2 of x plus 1. So if I want to identify the basic parent function of this, we would have y equals logarithm base 2 of x. That would be the, if I peel away the transformations, the negative out in front and the plus 1 within the parentheses, I end up with y equals logarithm base 2 of x. Its related exponential function, or its inverse, I can say related, but it's also the inverse function, would be y equals 2 to the x. And I do this because for a lot of people, they have a lot easier time thinking about the algebraic rules of, powers of 2 as opposed to logarithms, and it can be a good starting point. Now, in this particular case, we have two transformations to address. We have to address the negative out in front and the plus 1. The negative out in front is going to cause a reflection over the x-axis, and the plus 1 is going to give us a shift to the left 1 unit. We should apply these transformations in the order in which they occur according to order of operations. The plus 1 is in the parentheses with the x, so it would occur first. So I should shift to the left 1 unit, and then I should reflect over the x-axis. So now I have identified all the important pieces of information that I'm going to need to work my way through as I calculate points that I want to plot. One thing I can do is maybe identify the math that I need to do to accomplish each one of those tasks. For example, to go from a exponential function to its inverse logarithmic function, the graphs would be reflected over the line y equals x. In that case, I need to switch the x and the y coordinates. So the exponential function would contain the point 0, 1, and the logarithmic function, its inverse, would contain the point 1, 0. Similarly, to shift to the left 1 unit, since it's shifting to the left, that's a horizontal translation. I'm going to affect the y-coordinate. And when my graph shifts left, my x-coordinates are getting smaller by 1. So to accomplish this transformation, I'm going to subtract 1 from the x-coordinate. And when I do that, I would get the point 0, 0. Our last transformation, to reflect over the x-axis, I would need to take the opposite of the y-coordinate. And if I take the opposite of 0, which is the y-coordinate of 0, 0, I still remain at 0, 0. So this ends up being, the point 0, 0 ends up being the first point I would plot when I make my graph. And so we just continue this a few times. If we start with, if we have the point 1, 2, because 2 to the first is 2, I could apply the transformations. If you want some practice, you're studying, you're getting ready for a test or a quiz or something like that, you might want to pause the video, try to work your way across horizontally to the other 3 points to see if you can do it, and come back and look at the solution. The application of our process to the point 1, 2 would give us 2, 1, which would then become, let's see if I'm going to become 1, 1, which would then become 1, negative 1. And so that's another point we would graph on our function, negative logarithm base 2 of x plus 1. Let me give you a couple more points on the related exponential. 2 squared is 4. And 2 cubed is 8. If you want to try those on your own, apply the transformations to get the end result. See how it goes. Come back in a moment. For the point 2, 4, switching the coordinates gives me 4, 2. Shifting to the left 1 would be to subtract 1 from the x-coordinate. So my x-coordinate would become 3. My y-coordinate would stay 2. To reflect over the y equals x, I take the opposite of the y-coordinate. Similarly, 3, 8 becomes 8, 3 by switching the coordinates. 8, 3 becomes 7, 3 when I shift it to the left 1 unit, which then becomes 7, negative 3 when I reflect over the y-axis. So that's a nice set of points, probably big enough. We might now want to work with some points, however, that give us dealing some negative x-coordinates, some reflections, some fractions, that sort of thing. So if we had on our exponential function the point negative 1 comma 1/2, and the point negative 2 comma 1/4, and negative 3 comma 1/8. If you don't understand those points, you might want to find a video or read up on negative exponents, meaning that you take reciprocals there. Once we have those points, however, we can apply the transformations. Once again, if you want to pause the video, try it on your own, and come back and see my solutions. Applying our transformations, we have 1/2 comma negative 1. Oops. 1/2 comma negative 1, which would then become negative 1 1/2 comma negative 1, and negative 1 1/2 comma positive 1. Negative 2 1/4 becomes 1/4 negative 2, becomes negative 1 1/4. Ooh, I am not correct on those points. Sorry. I got to go back. This 1/2 minus 1 is negative 1/2, not negative 1 1/2. So these should be negative halves. I apologize. And 1/4 minus 1 would give us negative 3/4, negative 2, which would then become negative 3/4 comma positive 2. Negative 3 comma 1/8 would become 1/8 comma negative 3, which then gets transformed. 1/8 minus 1 is negative 7/8 comma negative 3, and negative 7/8 comma positive 3. So now we have all of the points that we need, and we will be focusing on our last column of points. All I need to do is take and plot those points. I'm going to take a quick look at my x-coordinates and y-coordinates to help me set up my axes. My x-coordinates seem to go between negative 7/8 and 7. My y-coordinates between negative 3 and 3. So when I go to my graph, it does look like I am going to need some negative x-coordinates. So I'm going to need a little bit of space in my on the left side of the y-axis. And that is because the vertical asymptote has been shifted 1 unit. I think I can set up a scale by ones here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I think I'm going to set up my scale this way. If you're graphing along, you stop for a moment, set up your coordinate plane, get it all set up, and then come back. So the first thing I'm going to graph is my vertical asymptote, which has been shifted from the y-axis to the x-axis. Y-axis to y equals negative 1 because of the plus 1 on the transformation there. And now I'm just going to go through and I'm going to plot my points. I'm going to do some screen flipping here because I don't have the points right on my screen. So let's see, 0, 0, 1, negative 1. So 0, 0, and then 1, negative 1. 3, negative 2, 7, negative 3. 3, negative 2, 7, negative 3. Negative 1/2, 1, negative 3/4, 2. Negative 1/2, 1, negative 3/4, 2. And negative 7/8, 3. And then we can see our vertical asymptote taking shape. Let's see here. And there we have the graph of y equals negative logarithm base 3 of x plus 1. For any other transformations, whether there's 2 transformations, 1 transformation, 3 transformations, or more, the same basic principles can apply of identifying the parent function, the logarithm, using the related exponential to help you get some points, and then simply applying your transformations. Applying your transformations in order, and we can do that. And hopefully you get to a point where you're proficient enough that you actually don't have to write anything down except for the highlighted numbers. That would be a good end goal of just being able to go straight to here. But until you become that comfortable, writing out the points is not necessarily the worst way to go. All right, hope you enjoyed this and you found it helpful.